All right, so who we missing again? Rebecca, Silas, and Freddie. That's how I do number one. I'm gonna erase it now. Okay. So
Pause the video.
screenshot. All right, here we go.
Oh, and you just missed it. No, the viewer did. I was watching.
All right, here we go.
Silas, I don't like your pants. Just kidding.
Silas, I like your backpack. I never told you that. By
Yeah, that's
the
a
way.
nice backpack.
It's a sweet backpack. Yeah. Oh yeah. Go ahead, explain. I don't want to confuse everybody, so we'll just do it out loud.
450 divided by 100 and
Oh, you-
4.5 and then multiplied it by 20.5.
Yeah, that's what I did.
I did that too.
That's
So you just did a different proportion. It's the same proportion, but you set it up a different way.
Yeah.
No,
Yeah.
I set it
You
up the
just do
same.
4.5
and then I
times
just
20 point.
You just did the
You did this left side there. You
I
divided.
did T2 divided by T1 and then I multiplied.
Right. So
it.
you didn't set it up the same way. Not the, you didn't
Well,
set it up the same way.
The original thing
It's
is
just
the
less
same.
work. It's the same thing. It's just
Wait,
less work.
T2 divided by T1, that's not gonna yield you.
It's just 450 divided by 100. You get 4.5 and then multiplied by 20.5.
Do that divided by that you get 4.5.
I think it's too much math from the
Hey,
I did that too. It's just easier way to get the same.
Well,
result.
I got the same answer.
Yeah. Okay. Let's just see if you got lucky or if it works. I think it works, but let's just write it down. So you did 450
It's just-
over 100.
No, write
No,
it the same
no.
way.
You write it the same
that-
way, and you just do 450 divided by 100, and then you get 4.5,
Just write
and then
it
you
and then
multiply
I'll
4.5 times
show you.
20.5.
Yeah, I understand what you're saying.
It's the same thing.
Well, do the talking.
So the way I thought about it was what times 100 equals 450, and I got 4.5. So
Yep.
I did 20.5 times 4.5 equals
Okay.
X.
Yeah. So to keep the same ratio, if you have to multiply the bottom by 4.5, you would have to multiply the top by 4.5.
Yeah.
Yeah.
Okay.
Yes. So I'm fine with that, and that's because it's a proportion with just four numbers. Number two, obviously,
doesn't work.
wouldn't work, right? So as long as you guys see that, yeah, that's fine. So you guys all did the same. I would never think to do that. But see, that's what's cool. No, but that's not a bad thing. I think that's cool when kids share what they do, or you explain it to someone else, or you show it up here. Because just because I didn't think of it doesn't mean it's wrong. It's just a different way to do it. And if that makes sense to some of you, I'm fine with it. All right, so that's good. That's good.
Sure.
And if you don't like it,
I hate it.
yeah, I don't like it either. But it's okay. It works and it's fine. All right, here we go. Number two, Quinn, read number two, please.
A 52.5 or
All right, listen, please. Go ahead.
A 52.5 liter weather balloon is sitting on the ground waiting to be released into the upper atmosphere. The temperature is 295 Kelvin, and the pressure in the water balloon is determined by 100.8
KPA.
kilopascal.
You just say
atmosphere-
KPA.
KPA.
Yep.
Once the weather balloon is released,
Stop. There's the change. Okay, once it's released. So everything after that is our twos. Okay, so everything he just read is our P1, V1, and T1. Everything after that will be the twos. Continue.
once the weather balloon is released, it rises to an altitude where the pressure in the weather balloon is determined to be 45.6 kPa, and the temperature is 262 Kelvin. Calculate the new volume of the gas inside the balloon at the higher altitude.
Okay, so I'm just going to start at the last part there. Calculate the new volume. That always means V2. New volume isn't V1 because that's the original condition. So that's where my X or question mark is going to go. So that's what we're looking for. Now let's go back to the beginning of the question, Quinn. What's the first pressure they give us?
100.8.
100.8 kPa. Good. What's the first volume?
52.5.
52.5 liters. Good. Okay, temperature?
295.
295 Kelvin. I just when we get in the thousands is when I start
Okay.
losing it, alright? I can do the hundreds. Was that Celsius or Kelvin?
Why is it
Why is it
5.2.5?
Yeah,
May
definitely.
2nd, 2005. That's what that is. I don't know. You guys even,
I can't count them all.
someone just say the date I got married?
Yeah.
No, I got married way after that. Not way, 6 years. But anyways, back to this. Is that right?
Yeah.
Yeah.
You talking smack, Corey?
Oh.
Go to hit unsubscribe from Corey. All right, here we go. P2, what do we got?
45.6.
45.6 KPA, and what's our T2?
252.
252. Now, is anyone confused with where I got those numbers? Like why I'm labeling where I'm labeling? Negative. Everybody's good. All right. Donovan,
Yeah.
set it up, please.
Alright.
Do you need me to move?
Well, I mean, I didn't, like, like, do you want me to, like,
I just want you to put the numbers in the equation.
okay. 52.5
Yep. I got you.
times 100.8.
Yeah, I'm just gonna, so what she said is fine. I just wanna clarify. So, pressure times volume. So the way I wrote it is how I wanna put it in, but she wrote it in reverse. That's completely fine. So if you wanna write 52.5 times 100.8 on the paper, it doesn't matter the order. Okay, so that's, I just wanna keep it consistent. Continue. Over.
Equals 45.6.
Sorry. Equals 45.6
X.
times X. Good.
And then over 295.
295.
Over 252.
252, right. And so there is our setup. Who's confused with that? Okay, so cross multiply. Multiply all three of those numbers. Who has that number they can read off?
5292.
5212?
5292.
5292. Does someone agree? I'd just like to have more than one person.
Yeah.
Okay, good. Equals, now, 295 times 45.6. Anybody? Times X, but. So what are these two numbers multiplied together?
Ooh, that was a big number. 1333584.
Wait a minute.
That's
Wait,
flipped.
okay.
That's the,
Yeah, so,
That's
Oh,
just the
1345.
top.
so yeah, alright, so hold on. These three numbers here should be bigger than that number. What is it? 133?
1333584.
Yeah. So
I
that's.
just didn't care about order. I just
Yeah, no,
didn't
that's okay.
one,
So,
so-
well, as long as you have the X with the right number.
Yeah, I do.
Yeah, okay. So, just to be clear, so we're not confused, when you cross multiply these three numbers, we get this number. 295 times 45.6, that was the other one. What was that?
13452.
Oh. Where the heck did that other number come from?
That's just the top two multipliers.
yeah.
Oh, got it. Sorry,
Yeah.
you said that. Alright, so this times X now, right?
Yeah.
Okay. Who's confused here? Yep.
I'm pretty sure there should be 3 3s on the left side.
Okay, maybe.
Yeah,
Yeah,
there
there
is.
is. That's one.
She probably said 3 and I only heard 2.
Okay.
That's my
I did too.
dysfunction. Alright, we good now? Looks in. Okay, how do we solve for X?
Divide by 134.
1, 3, 4, 5, 2. Divide by 1, 3, 4, 5, 2.
99.
X equals 99.1.
1.
Right, 3 sig figs. That has 4, everybody else has 3. Again, I didn't tell you about sig figs. In fact, are there any other decimals anyway? Oh,
Yeah.
there
Just a
were?
4.
There's a whole bunch. So anyways, 3 sig figs, but if you didn't round it, it's okay. What's the unit on that thing?
Liters.
Liters, right. If you ever get confused, just look, what am I solving for? Volume, what's that? Liters. Hold on one second.
Okay.
So, some kids really get confused with liters. I mean, units. In this case, it's liters. So, again, look back, what are you looking for? And then if you're still confused, find the other number that is the same unit. So, volume and volume. So, if that's liters, then this has got to be liters too. So, go back to the problem. It should help you figure out the units. All right, you can go, and I'm going to go over the next one. So,
Yeah, that's fine.
all right. Okay, let's go over number 3 fairly slowly, and then I'm going to have you work on 4 and 5 again. And if you got them right, then maybe I'll use you to help other people. All right, here we go. So, number 3. Kaylin, go ahead and read number 3, please.
A contained sample with a gas at 25 degrees Celsius is producing 65.6 kPa of pressure. If the volume is unchanged and the temperature is raised to 50 degrees Celsius, what is the new pressure exerted by the gas?
Good. What's the change?
The temperature is raised.
Good. Temperature is raised. So again, I would circle that so I know where the change is. Before it is my 1, right? My 1 are my 1s, and then after that change are my 2s. All right. So back to Kaylin here. What's held constant?
The volume.
volume. So that means we don't need V1 and V2. So these are going to be out of here. We don't need them. So it's just P1 over P2. P1 over T1 equals P2 over T2, which should be this. As temperature goes up, pressure goes up. And the reason I'm bringing that up is that the answer should make sense. Like in number 1, the volume went up. Does that make sense? In question 1, does it make sense the volume goes up? Yeah, because the temperature went way up. That's a significant change. 100K to 450K, that's a lot. Okay. Number 2, it's hard because you have everybody changing, everything changing, so it's hard to really think of it this way. That's why I didn't do that. Number 3 here, if the temperature goes up, pressure should go up. If temperature goes down, pressure should go down. We'll find out. Caitlin, what was P1? 65.6 kPa. T1.
25
Good, 25 degrees Celsius. P2 is what we're looking for, and T2 is 50, right? All right. Now,
Wait, didn't you want to Kelvin?
yep, I was just going to ask, what do we need to do first? We have to convert these to Kelvin, and here's why. Here's why. Okay, 25 to 50, is that number twice the size of that number?
Yeah.
Yeah, good. Let's convert to Kelvin now. What's this in Kelvin?
298.
298K, what's that?
323.
Is 323 twice the size of 298?
No.
No, not even close. It would be 596. 596 would be twice 298. The reason we use Kelvin for gas calculations is kinetic energy is directly related to only Kelvin. This doesn't work. Kinetic energy, how fast particles are moving, how much energy they have when they move, it doesn't work with Celsius, and this is why. When you double Celsius or triple or whatever, it isn't the same on the Kelvin scale, so therefore, I guess here's a better way to say it, the amount of kinetic energy particles have at 25 degrees Celsius is not doubled at 50. It's only doubled if you double the kinetic energy. I could do the whole math and show you the equation for that, but that's AP stuff. We don't need to really spend the time doing that. But it works out, like mathematically, the kinetic energy only doubles if Kelvin doubles, not Celsius. So I like to explain it because I tell kids convert to Kelvin, and most of the time they're like, okay, I'll just do it. And that's just because that's how it is. But I want you to have a little understanding. Don't just do it because I said so. There's actually reason behind it. All right, so anyways, this is 298. 298K. This is 323K. All right, go ahead, Jake, set it up.
65.6 over 298 equals x over 323.
There it is. And we cross multiply here, that's easy. So what's 65.6 times 323, Alex? All right, well, so who has it?
21,188.
Oh boy. 21188. 0.8. A lot of eights there. I almost got it all. Equals 298 times x. And let me give you guys some help here. Maybe I don't need to help you, but if you were to type in, look up here, you had a calculator and you typed in 65.6 times 323 divided by 298, you won't get the right answer. If you do it all in like consecutive order on the calculator, like all one line, it won't work. Of course not. Well, okay, maybe you get it, but some students who are they just kind of shut down with math, they don't really realize that. You can't just type it all in at once. And if you guys all got that, good. I'm not talking down, I'm not treating you, like you're dumb. I've seen it many, many times every year. Someone does that, a few students do it. So you have to do these two first, then divide by 298. Just be careful on the calculator because it'll do exactly what you type in. Kids will be like, this is broken, it's not working. And I have to explain it's the user, not the calculator. What's the answer? Anybody? 71.1 what? kPa. Very good. Does that make sense?
Yes.
Yep. Temperature went up, pressure went up. All right. So what do you need to show on a Regents or a test? You need to show this, at least this, numbers plugged in the equation, and then your final answer with the unit. This in-between step, I really highly suggest you do that. You write it down for your own benefit. But on a Regents, they just want to see this and that. You don't need to show all this. You don't even need to show that. Just show that you know where to put the numbers and how to get the answer. Okay. So on tonight's homework, I do need you to show work. You do not have to show this if you don't want to, but I really suggest you should. Alright, let's see,
The back.
who we missing here? The back, first I want you guys to pair up here. Corey wasn't here, so let's go Jake, oh, you didn't do this either, did you? We can do it now. Do 4 and 5 right now, do 4 and 5 right now. Jake, Will, and Alex, compare your answers. Donatica and Quinn, Shane and, oh, Shane's doing it right now. Alright, talk to this guy. You can squeeze over here and talk to this guy too.
Howdy.
Can we fix this real quick?
Okay.
Well, I just fixed it.
Yeah.
I did 4.
Yeah, so if you think you did it wrong, just fix them. Give me time.
2.9 something. I know that's not right.
I got 4.
Oh, okay, I got 4 too.
Like for the
I'm
first,
doing
the second
something.
time?
Hold on.
For the first time?
Oh,
Cause
I think I did it wrong.
like I don't know how, like, so we got P1, which you know you're really
I
good
got
volume.
0.34 if I did it like.
So I'm gonna use 155.
Well, no, Kayla, because I
So
got,
Shane,
I got 0.34.
Veronica, and Corey, at least try and get 4 done.
So this is what I did.
Wait, so
So
if
right
it's
here
this, or like,
is
Yeah, so
P1, right here is P2, V1, right? Right down here is the temperature.
Oh, yeah, I had the same thing.
Yeah.
Okay.
Yeah, I
You
forgot.
did
I
0.35.
prefer to come into one of them.
But if that is what I have, I
134.
think 0.34 is right. I just crossed it off. But you should do like, I would just cross it off.
Yeah. I just
You should divide by
didn't know
X.
how to do this.
So I did it backwards.
I
divided the wrong number.
So that's not right.
No, I read it backwards, but.
Because,
That's all the difference.
No.
yeah, but there's actual temperature, so right here, so you
So
know,
30,
Wait.
Yeah.
standard temperature and pressure, so standard temperature is 263.
so standard pressure right here, so.
See what he gets and then you go from there.
So we have 30 volume.
Corey, you need help?
We lose volume.
Okay, Shane?
And then for pressure 1, which is
Veronica?
STP right
Little help?
here.
Can I finish?
Yeah, like standard temperature and pressure.
Yeah,
Standard
yeah.
pressure is
You guys got the same thing? For both?
1.3.
Or
She's
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 doing-
6 and 5 now.
Yeah.
Oh, we got a ball.
I did a different way.
Oh, okay.
Yeah.
Which one?
Number 2.
Oh, I did all of them
You mean
different.
number 5?
Me, 202.
No, I'm just talking about that one. I did a different way than you did it and also got the same answer.
Well, I.
Is 6.75. That's where I'm coming from.
So
So
I,
I multiplied those together. No, wait, is that 2?
So if,
forget about
I
that.
multiplied those together.
count out the
Divide by that,
temperatures,
divide that,
temperatures are constant.
multiply by that.
So that's why I temperature.
Multiply
No,
by this,
I know, I didn't
Yep.
count that.
divide by that.
So I can times that by that.
Same
So I
math.
just did the original.
different.
All you're doing is making this one number and then putting it over
No,
one.
because you times it by the ST.
Same thing.
Figured that out.
Standard temperature, pressure can be 1 atm per 1 Celsius, which is added to the
Yep.
Will, I showed you how to do that question.
For what?
Exactly.
I just kept it at 1
You did?
That's why you wanna keep, that's why you wanna keep it as that. And then you times that by that.
I thought
And
that
then
was hard to
it equals that, which is that.
Which one you guys talking about, 5?
Yeah,
I did it wrong.
cause how much is one ATM, like one,
If I did 1 atm for standard temperature.
Wait, you don't need to use
I
too
just
much
kept it at 30
Is that right?
for the volume.
Yeah, I'm with you.
Is that?
Then you have to turn your 202.6 kPa into ATM. You have to have the same unit. You use ATM to ATM or go kPa to kPa. It doesn't matter. You have to use the same unit.
so,
Makes sense?
and then what I did, the KPA times 30. And then
Yeah, yeah,
that
no,
X,
yeah,
and then,
that's right.
alright,
So if you wanna use the one, you have to turn this into ATM. And the way you would do, you have to do a conversion.
Maybe I set it up.
The easiest way to explain it is just use root of 1. Just because if I give you kPa here, you should use kPa.
How was your
where's
equation?
ATM?
Does that make sense?
30.0
Where's ATM?
times
No, for
100.
like conversion.
Yeah.
Oh,
Okay.
it is, it's right here. So one ATM is 101.1 kPa.
Now, how about for,
So, okay,
So
so
couldn't you
if you wanted to
find
turn this number
What
in
the standard
ATM,
pressure
Yeah.
was until you told us.
Okay.
Well, I got
Because it's
15,
above-
but
because it's double that number.
okay,
That's equal to one ATM, so this would be equal to 2 ATM.
okay, so if you like say, like, say we got like 304 when you divide that, 304 by that would be an ATF.
Yeah, yeah,
Okay.
you don't really break it down, but that's how you.
But still, it's out here,
Yeah,
obviously.
yeah.
I got 15, but that doesn't make sense.
I got 15.
It's perfect.
I got 15, so.
What happened to the pressure? By how much?
But then should the volume go up?
No, we're gonna pressure.
Oh,
volume goes
right.
down.
Volume goes
Take a
down,
sponge,
pressure
squeeze
goes up.
it, takes
That
up
makes
less
sense.
space. Quinn, you wanna show us how to do 4?
Can I do 5?
Yep.
Yay.
Sure. I did it the way that will. That one.
Don't do it that way.
Oh.
This is far too.
I'll do it.
Okay.
I'll do both.
No, do 5. Who wants to do 4?
I did it the way Will did it.
How did you even do that? How
I'll
did
do
you
it.
come up with that? And why didn't you just cross both lines?
Well, he did on this one.
I did.
Oh.
I wanted to do it, so I started just.
Alright, who wants to
It's the
do
same thing,
4?
it just
No.
stops
Denonica's
you from
gonna do
getting big
4.
numbers. It just makes the
Hey,
numbers
hey, hey.
smaller.
Do 5 on the right. What are you doing?
I'm not.
4 over here, 5 over there.
It's not fair.
You're gonna be going 5, 4.
Why is that the first thing you go to?
1,188.8.
Simplify that side. And then
Oh, we're recording this whole thing. It's kind of a lot of oh yeah, there's Tyler.
Caitlin.
Sometimes we call him Trevor.
Like an